Barklage. Go ahead and I'm a geophysicist at the Illinois State Geological Survey, and my research interests revolve around subsurface imaging, so similar to like a CAT scan or an MRI of the human body, only of the subsurface of the Earth. And the PI on this project that I'm going to talk to you about today is actually my colleague Robin Mateus, who's a coastal geologist at the Illinois State Geological Survey. And then we have a couple of co-Is here. And then I'd also like to highlight our student intern, Leanne Rosario, who's been working on this project with this data. And she came to us this summer as an intern through the Edwin G. Potter internship program that we have through the Illinois State Geological Survey to provide opportunities for historically underrepresented groups. And we've really enjoyed working with her, and she's earned her way onto the payroll now, and she's going to continue to work with us while she finishes up her studies at UIUC. Okay, so our project objectives are pretty simple, and they build off a lot of what Carrie was just talking about. We want to map the sand thickness and the subsurface geology of Chicago's coastal environment. So we're taking sort of a more focused approach, focused on the Chicago beaches and the Chicago lakefront. And so again, I show the lake level curve here. We've been in recent high lake levels. These two photos on the right here show one of the beaches here. I believe this is 63rd Street Beach. I'm not exactly, I forget. Anyway, in 2013 in the top and 2020 there at the bottom. And you can see how different that beach looks. And everyone gets concerned when lake levels come up because they say, oh no, my beach goes away, it's all gone, where does all the sand go? But actually, one of the things we're discovering with this project is that during these periods of high lake levels, you have increased deposition. So you're actually adding sand to your beaches. While it looks like your beach is going away, you're actually accumulating sand on these beaches. Next slide. Okay, so this is a first year of a two-year project, and so some of the key deliverables, some of the key project milestones and accomplishments from this year include the acquisition of two large geophysical surveys. And the first was a ground-penetrating radar survey that we conducted onshore on the beaches of Chicago, and that involves dragging around this little radar antenna along the sand that measures the thickness of the sand and the subsurface structure. And then we also rented an instrument called a sub-bottom profiler, which is a seismic imaging system that we deployed from a boat just offshore to measure the sand thickness as you go out into the lake. And these maps show all those transects that we were able to acquire this summer. Next slide. And so this is just an example of the data. So over here on the left is an example of the seismic data. And we can see a bunch of interesting features in this data. So this is the top of the water. This is the lake bottom here, shown in red. And then we have this just thin veneer of sand at this area, maybe about 1 to 2 meters thick. And then beneath that we have some other interesting features here, and some old buried channels, Paleozoic bedrock outcrops, and we can see some layers onlapping onto that. Over here on the right is the ground penetrating radar data, and that we have maximum resolution there of about well, maybe 5 to 10 meters below the lake bottom. And then on the right here is this ground penetrating radar data, and this is a cross section of the subsurface. So the horizontal axis is distance, the vertical axis is depth, down to about 8 meters here below the bottom. And you can see in the top section here we have these nice coherent reflectors that represent the layers. And then beneath it we have the till. That black line shows the base of the sand, which we're trying to measure. Next slide. So our next steps, we're going to continue to process and analyze and interpret this data, construct these sand thickness maps, and we're going to present those results at the AGU fall meeting. And we have we're setting up a meeting now late in spring with the various stakeholders who will use this data, and then get ready for year 2 field work, which is going to include some coring and grab sampling. Thank you.